Right, so I just knuckled down and put in, basically I've added an algorithm which reads the analogues as many times as it can within a second and then averages them. So I know the way it works is you got an algorithm here which basically it runs this stat every second, and it has to use what it is. It's a bit complicated, but basically I've got a timer in there, and the timer runs essentially at 15-ish K, 15625 hertz, right? And so I've got a counter here for the same value, okay, and then of course it's just basically counting up here until it hits that, and then it runs stat. So it runs every second, and then asynchronous to that, I've got this loop, the main loop. Essentially all it's doing is just reading and then adding to the total for that specific ADC. So it accrues a total for that ADC, and then it records the number of times it's actually read. And so in the stats algorithm, which runs every second, basically it just reads the total, divides it by the number of counts, so it gets the average, yeah, and that then becomes the value that it uses, okay, and then it prints those out. And currently, as you can see, we have 5,521 reads, so it's pretty smooth. And as you can see, the only way you can tell, you get the odd digit swap here, but that's probably because it's borderline between the two. I could probably show the next digit now, to be honest. But you can see how stable it is now. I mean, look at that, 4.07, 3.58, and this is obviously like, say, 3.985 or something, isn't it? And then we have the voltage in that it's reading, which is 1154. So really, really stable, which means these noisy graphs that I get will now be really nice smooth lines, which is good. And you could even alter it to read even more, because the voltage doesn't change that quickly. I'm only doing 1 second updates just because it gives me something to track, but I could quite easily make it 1 minute updates now. I'm worried about the size of the, because you're dumping it into a long, which in this case is 16-bit, I think, in this one. Oh, excuse me. It might not be. No, I think an int. An int's 16-bit, so that means a long's 32-bit. So we've got up to 4,000 million reads. I don't want to say billion because it's ambiguous, but 4,000 million reads, 4 gig. Each read can be up to 1,000, so that means we can read up to 1 million reads. Well, okay, I don't think we'd do that. I mean, this is 5,500 reads a second, so obviously we can then turn that up to a minute, and it would be 60 times that. Still well within 1 million, so we should be all right. Yeah, and also I can probably optimize this a bit better, because we're currently reading all 16, but obviously most of these aren't even read, so we can even make it faster, and read more times. And but it's working, and I don't like this I don't think is necessary either. Originally it was because we're reading them in sequence, but now because we actually have an array, we don't need to do this. It's done here and then dumped into an array, and then we can just simply output from the array here, so it's probably easier to do it that way. So I need to alter it, obviously, but yeah, so I just thought I'd update with that. It's currently on, it's actually 12 volts. This is reading 11.5, I don't know why. But it's on 12 volts, and the current's reduced now from 1 amp, so obviously it's on constant voltage now. And we've obviously got, this is the one that's currently being charged asynchronously, if you like. Yeah. And we've got 3.89. This is the one that was charged, that I took it off. Now this one is now being charged asynchronously. It's not the right word, but you know what I mean. And then we've got here we've got 4.07, which is the one of the. These two cells are actually good. It's this one that's the duff one, but it's staying quite stable actually. Although we are charging. And what I'll do before I go in about an hour is I'll switch this off, and then it will then cell balance just on the battery alone without a charger attached. Yeah. But this will now give beautiful straight lines instead of all this noise that we have to interpret. Yeah, because it's reading the ADC 5,500 times and then taking an average. Yeah. So, and that's what they expect. Yeah, so that's pretty good. Even the ones that aren't even connected are still quite stable, aren't they? You know. Yeah, and it's updating every second. So basically, if I was to change the voltage, then 1 second later it would be different, completely different. It's not keeping it's not doing like a moving average or anything. No, it's just literally accumulating the reads, 5,500 reads over the second that it has, and then divided by that 5,500 to give the actual value, and then that's calculated. The voltage is calculated off that, so that's pretty good. Yeah. Anyway, there you go. One update. Yeah. Let's. We can check it actually, because now we can actually see an accurate voltage. It's pretty good. So this is the first cell, which is on 389. Yeah, you see that's on 358. Is that right? Yeah. So it's actually reading wrongly now. 3.9 volts. Yeah. And if I move this one just to the middle cell, it will give us it'll obviously give us a negative voltage because I'm connected it the wrong way, but it'll give us a voltage 4.09. You see that one's saying 4.05, so that's reading slightly low. This one's reading low, and then we've got the last cell. I'll just swap it over. To the last cell. 3.99. Oh, that's pretty good, isn't it? Look at that. Yeah, 4. And that's on 3.9. So they're all offset. So what I probably have to do now is actually recalibrate the voltage based on the first cell, the voltage reading from the first cell, but without the cell balancer attached. Oh, bollocks. Let me just get this push off. There we go. So it's not in the way. Yeah, but the cell balancer is obviously working, isn't it? Let's see what the full voltage actually is now. 11.98. Yeah, so that actually is more aligned with the power pack itself. Yeah. So the first cell which goes into there, doesn't it? Yeah. So the first cell is actually 3.9. So what I need to do basically is perhaps recalibrate. The first cell is just reading directly from the cell, you see. So the 358 that we've got, what I can do is I've got an adjustment algorithm here for the actual ADC read. So I need to adjust that, and then I'll need to adjust these as well so that they're more accurate. Interesting that, isn't it? Anyway, yeah. Okay. So I'd update with that.